Look closely at the modern supply chain. The wooden pallet is the true backbone of global trade. Whether it's our food, medicine, or electronics, almost every physical good relies on this simple grid to move across the world. Consider the scale. At any given moment, there are over 2 billion wooden pallets in circulation in the United States alone. It is a quiet infrastructure, but one that is absolutely vital. Logistics experts estimate that if wooden pallets disappeared tomorrow, the global food supply chain would collapse in less than 48 hours. A standard pallet is an engineered component, not just scrap wood. It consists of three primary parts. The stringers act as the core support frame, providing structural integrity. And finally, the bottom deck boards, which distribute weight across the warehouse floor. The open space between the boards is precisely engineered to allow standard forklift entry, keeping the entire load stable and uniform. The Grocery Manufacturers Association, or GMA Pallet, is the North American Logistics Foundation. Measuring exactly 48 inches by 40 inches, it is the industry standard for shipping and storage. Why this specific dimension? Because it is engineered to perfectly occupy space in 53-foot trailers and ISO shipping containers, minimizing wasted room. By standardizing the 48 by 40 footprint, the entire supply chain functions with mathematical precision, ensuring that goods reach their destinations with maximum load stability and minimal downtime. Engineering a pallet requires balancing the lumber-to-load ratio. This determines how much weight a pallet can carry relative to the material cost. Manufacturers choose between softwoods and hardwoods. Softwoods like pine are common for cost-sensitive general-purpose shipping. Hardwoods like oak provide the durability required for heavy, industrial loads. The choice comes down to the application. Matching the lumber grade to the specific payload requirement ensures the pallet remains functional, affordable, and safe. Pallet construction relies on choosing between two primary wood types, hardwood and softwood. Hardwood is dense and durable, engineered for heavy-duty, multi-trip logistics cycles. In contrast, softwood is lighter and significantly cheaper, ideal for one-way shipping and lighter load requirements. Ultimately, the choice is a strategic balance. Manufacturers must weigh the upfront cost against the required structural longevity for their specific supply chain. Precision is the foundation of modern logistics. Every component of a pallet begins as raw lumber that must be milled to exact, standardized dimensions. High-speed industrial saws slice the timber. Accuracy here is vital. Even a margin of error of a few millimeters can prevent a pallet from entering the precision racking systems of a modern warehouse. The resulting boards are then trimmed to specific lengths required for the stringers and deck boards, ensuring the final assembly meets the rigid requirements of automated machinery. In the world of automated supply chains, there is no room for variance. Precision is what keeps the global economy moving. The stringer design is a classic engineering choice. It uses continuous structural beams called stringers to support the load. Because these beams run from end to end, forklifts can only access the pallet from two opposing sides. In contrast, the block design replaces continuous beams with individual corner and center blocks. This open structure creates gaps that allow a forklift to approach from all four sides, offering maximum agility in tight warehouse aisles. By enabling four-way entry, block pallets are often preferred in high-density storage environments where space is at a premium. Historically, pallet assembly was a manual, labor-intensive process, relying on individual craftsmanship with handheld tools. Today, industry has shifted to high-speed robotic assembly lines. These systems handle thousands of components per hour with unmatched efficiency. Precision-controlled pneumatic systems drive nails in consistent patterns. This automation ensures every joint is uniform, directly contributing to superior load distribution. By removing human error, these robotic lines minimize in-transit failure rates, creating a safer and more reliable global logistics foundation. Pallet longevity relies on safety by design. A common failure is pull-through, where the nail head rips through the wood under load. Engineers drive nails at specific angles. This cross pattern creates mechanical resistance, preventing the board from separating during heavy forklift operations. Proper nailing patterns are the vital difference between a secure load and a dangerous forklift accident. Every international shipment requires a passport for its packaging. This is ISPM 15, the international standard for wood packaging materials. Untreated wood can harbor destructive stowaways like the emerald ash borer. These pests can decimate entire forest ecosystems when they escape into new regions. To combat this, the IPPC created ISPM 15. This global regulation mandates that raw wood be treated to neutralize pests, effectively making it safe for international borders. This stamp is the visual proof of compliance. Without it, your product cannot legally pass through international trade networks. To ensure pallets are safe for international travel, they must undergo a rigorous heat treatment process. This is essentially cooking the wood to eliminate any pests. The wood core must reach at least 56 degrees Celsius for a minimum of 30 minutes. This internal temperature is the global standard for pest eradication. This modern method has completely replaced hazardous chemical fumigants like methyl bromide, which were previously used but are now largely banned for this purpose due to their toxicity. By relying on heat rather than chemicals, the industry ensures global supply chains remain secure and environmentally responsible. The ISPM 15 stamp is effectively the passport for wooden packaging material in international trade. It contains essential information: the IPPC certification logo, the country of origin, the unique facility ID, and the treatment method used. The HT mark stands for heat treated, confirming the wood reached the required core temperature to neutralize pests. Without this specific stamp, pallets are strictly prohibited from crossing borders and are frequently rejected at customs, causing massive logistics delays. This simple imprint ensures global biosecurity, protecting native forests from invasive species carried within wooden packaging. A pallet represents more than just wood. It is the structural base of global logistics. When it holds, everything is stable. But what happens when a pallet fails? The collapse of a load is not just a damaged pallet. It is a catastrophic supply chain interruption. Economically, the cost of a pallet failure is massive. Cargo damage, production delays, and labor safety risks mean the actual cost of a failure is 10 times the price of the pallet itself. This is why quality control is not just about wood selection. It is essential risk management to protect the entire business. The logistics industry is shifting from a linear model of buying and disposing of pallets toward a more efficient pooling economy. In this model, companies rent standardized pallets from providers like CHEP or Pico. The provider manages the retrieval, repair, and redistribution, drastically reducing waste. By pooling, companies ensure high-quality, durable equipment is always available, turning a logistics cost into a manageable service. Modern logistics demands total visibility. Today, wooden pallets are no longer just wood. They are smart assets. By integrating RFID tags and QR codes, every pallet now carries a digital passport. This technology tracks the pallet's birth, its repair history throughout its life cycle, and its exact current location in the supply chain. This shift to digital transparency enables a circular economy, significantly reducing waste and optimizing global delivery. "90% of wooden pallets are recovered and repaired. Damaged deck boards are removed and replaced to restore structural integrity. Once repaired, the pallet is inspected and re-stamped, extending its functional life by years. This recovery and repair cycle keeps millions of tons of material out of landfills annually. When a wooden pallet is deemed unrepairable, it does not head to a landfill. Instead, it enters a highly efficient circular loop. The damaged wood is fed into an industrial grinder, where it is shredded down into uniform raw material. This material is then repurposed into one of three critical streams: organic landscape mulch, durable particle board, or industrial biomass fuel. By converting waste into resources, the pallet industry maintains a nearly perfect circular economy, minimizing waste and fueling modern manufacturing. The modern logistics industry is undergoing a shift known as the Safety by Design movement. This initiative ensures every pallet is engineered not just for containment, but for survival in high-speed, automated environments. With high-speed warehouse robotics, pallets must be uniform. Inconsistent dimensions or protruding nails can trigger emergency stops or cause catastrophic product jams. Industry audits now mandate specific, repeatable nailing patterns. This eliminates the pull-through effect, where fasteners fail during forklift operations, ensuring structural integrity from the first mile to the last. By leveraging performance data, manufacturers refine designs based on real-world failure stress tests. This cycle of auditing and optimization defines the modern standard for global supply chain safety. The wooden pallet is a model of modern sustainability, operating as a near-perfect circular economy. Nearly 90% of wooden pallets are recovered and repaired. This drastically extends their lifespan and keeps raw timber in the system. When a pallet finally reaches its end, it avoids the landfill. Instead, it is shredded for mulch or converted into renewable biomass energy. By integrating sustainable forestry, repair-focused maintenance, and renewable end-of-life processing, the pallet industry sets the standard for responsible industrial logistics. The 2026 logistics landscape faces significant pressure. Manufacturers must balance rising timber costs while strictly maintaining the load-bearing requirements of global supply chains. To mitigate costs, the industry is increasingly adopting engineered wood components. By layering wood fibers, manufacturers create materials that offer consistent strength while reducing reliance on premium, high-cost raw timber. Manufacturers are also shifting to mixed species compositions. By blending different wood types, they optimize material usage to ensure pallets remain stable and cost-effective for modern shipping demands. Global trade utilizes incredibly advanced technology. From massive container ships crossing oceans to cargo planes reaching the corners of the earth, our supply chains are marvels of human ingenuity. Yet, every single movement ultimately depends on this simple, standardized tool, the wooden pallet. No matter how advanced the ship or plane, cargo must eventually rest on this frame. It is the universal language of logistics. These dimensions ensure that goods can be moved seamlessly between trucks, warehouses, and ships without ever being manually handled. It is truly the infrastructure that keeps our world moving. We have journeyed from rough, raw timber to the precision-engineered backbone of the global supply chain. The pallet's evolution is remarkable. It is now a precision tool, a tracked smart asset, and finally, a core component of the circular biomass economy. By integrating RFID and sensor technology, these forgotten structures have become data-rich contributors to supply chain transparency. From the warehouse floor to international ports, the pallet remains the unsung hero of our modern world. Without this hidden infrastructure, the global economy would simply cease to function.